Transformational geometry is the geometry or the study of movement of objects on a plane. Now, this is rigid movement, which means that the size and the shape of the object does not change. We are simply moving it from one position on a coordinate plane to another position. We're only going to look at one type of transformational geometry today, and that's going to be translations. Translations literally mean to slide. So you're moving from one position to another position, but you are not changing the direction of the shape. So I can slide it straight across. I could slide it kind of diagonally, but as long as I'm sliding it and I'm not doing anything else with that object, that's a translation. Now, translations go from one position to another, so we need to know what was the original polygon and what was the moved one. So what we do is we do what is called prime notation. So this is my original A, B, and C. But then I see these little tick marks. Those tick marks mean those are the moved position. So this is where I started with A. This is where A ended up after it was moved. This is where I started with B. This is the moved B. This is where I started with C. This is the moved C. So always look for the tick mark, and that's going to show you that was the moved figure. Now, I'm going to teach you kind of an easy way to actually do the movement without really having to figure out how far to move the object. So we use rules when we do this. So when I'm using this rule, what I'm saying is, okay, the arrow is showing me where it's going. This is my beginning position. So for point A, if I began at -5, 10, and then I want to move it, here would be my move position because that would be A prime 4, 10. Now, when I go to describe that in words, I always start with my X value. So your X would always be considered the first movement. So when I move this, this figure slides 9 positions to the right. So when you're moving on your X, remember it's right or left. When you're moving on your Y, it's up or down. Here in this example, the Y did not move. So we can write this as a rule, or we can write this using words. Now, here's going to be a code which is called coordinate notation. And this is really how all transformations are written. So when we read this, the very beginning part of the code always shows us our original position of our object. So it says XY, that's just the ordered pair. Then I know there's movement because I see the arrow, and then it's telling me X plus 1 and Y minus 6. Well, here's kind of a general rule. If you're adding to the X, it means you're moving right on the coordinate plane. If you're subtracting from the X, you're moving left. If you're adding to the Y, you're moving up. If you're subtracting from the Y, you're moving down. That's our general rule. So let's see how this actually works. All right, so I've been given these 3 points. P is -5, 4, Q is 1, 4, and R is 1, 1. And so here we can see that's my original figure. It's a triangle. And I've been told I want to move this by a translation, and I know it's translation because I see an X plus 1 and I see a Y minus 6, so I'm sliding it. Well, I literally just put the coordinates in. I don't have to do it on the coordinate plane. So I'm going to do -5 plus 1, which I know is -4. And I'm going to do 1 plus 1, which is 2, and 1 plus 1, which is 2. So I now have my new X values. But I can't graph it until I have my Y values. So I know my Y is -6. So I'm going to take 4, and I'm going to subtract 6. I get -2. I'm going to take 4 minus 6. I get -2. I get 1 minus 6. I get -5. Here is my image. Those are the coordinates I need to graph on the coordinate plane to get my moved position. So I come down here and I do -4, -2 for P. Now I call that P prime because it's the moved position. And I have for Q 2, -2, so that becomes Q prime. And I have 2, -5, that becomes R prime. And you can see that I slid it down and I slid it 1 position to the right. Now, remember, we always talk about the X position first. So I would say X moved 1 unit to the right, y moved 6 units down. So that's my translations, which is a part of transformational geometry. You're only to be using the code. If they tell you how the movement happened in the code, just use the code in order to find your moved position of your figure. So good luck today as you try your translations. I think it'll be pretty easy. Have fun.